Okay, newest part, finding the inverse. So the inverse means there's two types of inverses. One is to switch x and y around and solve for y, which is what the bulk of this is. So h of x I'm just going to return into y, and this is the x, and I'm going to switch x and y around, switch their spots. They're going to, and my job now is just to solve for y, get y by itself. So you are working backwards in the order of operations. So the first thing I'm going to do is add 4. So on this side, I'm just going to have x plus 4 now. You can't make it 4x. They are not like terms. And then over here, I still have the 1/2. And now I'm going to get rid of the half, so I'm going to multiply by the reciprocal. And that becomes 2 over 2, which is 1. That's why they're gone. And I'm going to multiply this whole thing by 2. Okay? So real quick, that means I'm going to get 2x plus 8. So moving over here on the left side of the wall. And on this side, I still have the y plus 8. Oh, sorry, 3 cubed. And now to get y by itself, I'm going to get rid of the exponent. So I'm going to cube root it. So it means on this side I just have the cubed root of 2x plus 8. And on this side I have y plus 3. And now it'll get y by itself. I'm just going to subtract 3 to the other side, which this is in the cubed root, and that minus 3 is going to be outside of the cubed root, and that's your function. And then you can replace y with the inverse notation. So here is my inverse right here. That was a tougher problem. All right, next one. Find the inverse. So I'm going to make this y. Then I'm going to switch x and y around. And now I'm going to get y by itself. So working backwards in the order of operations, there's no addition subtraction except inside the radical, but I can't get to that until the radical's gone. So I'm going to move the multiplying. Since they multiplied by 2, I'm going to divide by 2. So x over 2. You could also write it as 1/2 x if you want, doesn't matter. With the square root over here. And now to get rid of the exponent or the radical, to undo a square root, I'm going to square both sides. And that means I'm going to square all of this, or this, whichever you want to look at. So anyway, on the right side of the equal sign, we're just left with y minus 5. On the right side, I'm going to square the x for x squared, and I'm going to square the 2 for a 4. Or I'm going to square this x and 1/2, and 1/2 times 1/2 is 1/4. There's the 1/4. And now to get x by, or y by itself, I'm just going to add 5. So the way I'm going to write it is 1/4 x squared plus 5. And then again, you can replace y with the inverse notation. And there is your inverse. All right, last part. Oh, not last part, but for the new stuff. We're going to use composite functions, and we're going to see if these really are inverses of each other. So the idea is, if I take g and put it into f, or if I take f and put it into g, when I'm done simplifying it, I should get x in both of them. So first I'm going to take g, and I'm going to put it right in there. So the x is going to go away, the 2 will still be there, but in its place will be 1/2 the square root of x minus 1. And normally x was squared, now this is squared plus 1. And I'm going to go through and I'm going to keep track in this little box in the middle of what I do first. So the first thing I'm going to do to clean this up is just square both things in here. So I'm going to square the 1/2, so that means 1/2 times 1/2, which is a 4th. And I'm going to square the square root, which gets rid of the square root, and I have x minus 1. Okay? Now I still have a 2 that applies to everything in here, so I'm just going to put that right here. So the first thing I dealt was the exponent. And now, so I guess those, the 2's, I don't know how you would say it. And now I'm going to multiply 2 times a 4th, and I'm going to get a 1/2. And then it's a 1/2 with x minus 1 plus 1. And now I'll multiply this in and get a half minus a half, sorry, a half x minus a half. So I'm not going to be getting to just x, because in the end, when I add the 1/2 and the 1, I'm going to get a half x, and then that is just a half, and I don't have just x. So there's no way that these are inverses of each other. So this answer is no. If it doesn't work for one, don't bother trying for the other. Okay? Okay. So let's try this one now and see if these are inverses of each other. Okay? So the idea is I'm going to take this, same idea, when I do the composite functions, I should get x. All right? So first, I'm going to do this one. G is going to go into F. So all of this is going to go right in there. Okay? So if you notice, I mean, these are kind of similar to each other. Those are the same, but these are different. So the 2 is going to stay there, and x is going to go out of the way. And in its place is going to go this square root of x minus 1 over 2. And now all of that's going to be squared with 1. So the first thing is to clean this up is I'm going to square what's in here. And when I square, I'm just squaring the square root. So the square root is now gone. They've canceled each other out, and I have this. So I dealt with the, I guess, the exponents first, kind of like that box. And now I'm going to do some multiplying and dividing. I'm going to get rid of the 2s. So 2, look at this as a fraction. These 2s are just going to cancel out. So then I'm left with the x minus 1s. So I got rid of the 2s next. And then the 1s can cancel out, so I got rid of the 1s last. And when I'm done, I just have an x. Okay, and this order does matter, because when we do this here, we're going to actually do it backwards. So this time F is going to go into G. So all of this, sorry you can't see that, is going to go right in there. So here's my square root. N for x is going to go 2x squared plus 1. And then you still have the minus 1 over 2. And now we're going to work backwards with how we get rid of things. So at the end, I got rid of 1s. Here, I'm going to get rid of the 1s first. These will cancel out. And I just have 2x squared over 2. Then I'm going to get rid of the 2s. The 2s will cancel out. So now I have the square root of x squared. And now the exponents, radicals, will cancel out, and you'll just get x. So these are inverses of each other because I both got x. Here I never got to just x, so they're not inverses of each other. All right, this is the last problem. Okay, determine the domain of the following functions. So the idea is you should be able to look at these without graphing them and tell me the domain and the range. So first, a cube root looks like this with infinity symbols. And so as was discussed on the graph on the front, this is the domain and range of infinities, like we did here. Okay? That's not going to change even if I stretch it, make it go right 5 and up 1. They are going to stay the same domain and range. So x goes from negative infinity to infinity, and so do the y's. Okay? So in this one, the flip will just make it go like this. And while this stuff might change, you know, x is going to the left, it's getting smaller, but y is going up, it's getting bigger. And to the right, x is getting bigger, but now to the right, the y's are getting smaller. The lowest x is still negative infinity to infinity. And the range, the lowest y, is still negative infinity to infinity. So with cube roots, this is always your domain and range. Always the same, no matter what. No matter your stretch, your flip, your left, your right. Now, square roots are something different. Normally, this starts at 0, 0. The stretch isn't going to do anything to 0, 0, but the 4 is going to make it actually go left 4. So now it's starting at negative 4, 0. And then when I put the infinities here, so now when I do my x, it's going to start at negative at 4 and go to infinity. But my y's will still be 0 to infinity. Okay? And this one, again, normally it starts here, but now it's going to flip, and it's going to be this dash line instead. All right? But it's still 0, 0. And then it's going to be going right 3 and up 1. So the final shape is going to be this purple line, starting at over 3, up 1. And now when I do the arrow, x is going to the right, so it's infinity, but the y's are going down to negative infinity. So when I do my domain of the purple line, my first x, my lowest x is 3, my biggest x is infinity. So 3 to infinity. When I look at my y's between 1 and negative infinity, the lowest y is negative infinity, and the biggest y is 1. Okay, so always smallest then largest. And that is your review. Definitely some challenging problems, but hopefully we've had enough practice.